Yeah, on behalf of Maharaja Sayajirao University of Baroda, uh, the Senate members, syndicate members, Vice Chancellor's office, Registrar's office, and the entire family, we wholeheartedly welcome you, sir. Professor Niyogi is a reputed academician and a researcher and a contributor in the field of varieties of field, had it been an atmosphere or the climate change or any other related and allied areas. We are really very grateful to have you, sir, here today in this webinar. And I'm very sure that this webinar is going to give so much of inputs to all the members who have joined here. Maybe the researchers, faculty members, or there are few people who are very curious to listen you. I would not be taking much time, but we would now request the further formalities and to obtain knowledge from the Niyogi sir. But before that, I would like to request Vice Chancellor sir to give the welcome address. And sir also has a very close inclination towards the environment, and I'm sure he is also willing to share his thoughts on that. So over to Vice Chancellor, sir. Thank you, sir.
Good evening, everybody. I hope now I'm audible to all of you.
Yes, sir.
Oh, so nice of you. Good evening and Namaskar, Prasad Dev. We welcome you to the Maharaja Sayajirao University of Baroda. So happy to have you here, and I'm very happy to share with you that Honorable Chief Minister of Gujarat, who has for the last couple of years, I would say, the state of Gujarat has faced many challenges, and recently, even just before a couple of days back, we have faced, a similar kind of a challenge, pertaining to climate, and it has been managed well. As Sanskruti, the founder director of the Institute of Climate Change, which is now it has been inaugurated by our Honorable Chief Minister Vijay Rupani ji, and it is a very, very pleasant experience for us to get your views on a topic which I believe, if I confess, if I admit, it has been neglected, by the country. I won't say that there is a lack of political will, or there is a lack of political commitment, but I strongly believe that the entire world which is passing through this COVID-19 is also an outburst of the kind of a lifestyle that we have adopted, the kind of strategies that we have adopted for industrialization, our negligence, or our I would say that a very, very disappointing approach to use of renewable resources. And when I was told by Sanskruti that yes, we are going to have a webinar on climate resilient cities, I just made an attempt to understand the importance of climate change. And it's not that we don't understand it, but I'll tell you what I have understood by looking at some of the reports which are available. I'm sure Sanskruti and her team is very much aware of these. But the real problem that now India is going to face, if I look at couple of findings of these reports which are available, that we are expecting average temperature to go above 0.6 degrees Celsius. It has already gone up, and it may go further up. And because of that, there's another very interesting report which is available to us from IPCC, which is very critical in evaluating the efforts put in by the Government of India and other institutions on climate change. And there is a possibility that if we'll not now start taking care of climate change, if we'll not address the serious issues, the country is going to face a situation like erratic rainfall, rising sea levels, and then we are also facing flood and famine. And now it has become obvious that one part of the country is facing famine, the other part of the country we have to manage flood situation. I think these are these kind of situation that we are facing. What I personally believe is that it's very, very important to note the efforts are there, but it's important to note that the same IPCC report is expecting the rise of global temperature, if the efforts are not made. And it's very shocking to learn that India is currently the fourth highest emitter of carbon dioxide in the entire world, and that affects climate change very, very seriously. So today we had a very interesting seminar because we are celebrating World Environment Day, and Honorable Prime Minister in fact wanted the entire country now to focus on biodiversity, um, to reflect on this institute which is in a very, very infancy stage of our university. In fact, there are a number of opportunities that are available apart from whatever the objectives that we have identified for these Institute of Climate Change. But what is required, what I understand is that we, the academicians and the universities and the research institutions, we really need to put in a lot of efforts for these studies. In fact, what is being now experienced as far as the climate change is concerned is that in the country, at the country level, we have a very, very limited data. In fact, it is expected that we have to build good climate models. We need good climate change projections. Even we have to take it at the district and the block level. And yes, we really need to make a very strong and sincere commitment, to address the issues of the climate change, which I think is lacking. Another alternative strategy that I wish Sanskriti and the institute should adopt is to build a network with the other institutions in the country and outside, and to get the expertise available not just nationally but globally. And we really need to carry out studies, distinctive studies, maybe in the different areas. Because of the lack of time, I won't go into that detail because we have Prasad Dev who is going to guide us. I'm very happy to share with you. Already questions have started coming, in the Q&A. But we really need to carry out various kinds of studies. We need to build network of, with the various institutions. And one area, I think, which we really need to, aggressively address, Sanskriti, what I understand is the agriculture, because it is directly affecting agriculture. There are other issues that we find because agriculture is also affected by the climate change, because there are certain issues which are generated also because of agriculture. But then we have to see to it that on the coastal land we have started permitting industrialization, we have started permitting residential activities, and all that is affecting. I don't know, we all have read in the newspapers that now because of this lockdown, now of course we are in the unlocked, we have already unlocked the lockdown, but then we could see the responses that we have received from nature, animals. I think this earth is not meant only for us. There are so many other creatures that they live, and we have to think about them. And I believe that all over the world, including our country, we have to start saying no to the vehicles, saying no to machines over a period of time. So I think before I close, I would be very happy because today's topic also is related with the urbanization. As you know that in our university, we have also set up Center for Urban Studies. What I understand is that there is a collaborative approach which is required. There is an interdisciplinary approach which is required for a climate change, because each and every one of us is affected. So I believe this institute would become a hub. It would bring all the researchers together. And I think I'm very happy to learn, because I was looking at some of the objectives that you want to set up Center of Excellence, you want to start a couple of courses. I expect, Sanskriti, that let's start with some basic foundation courses where Prasad Dev can help us at least to develop awareness. I think that is the first and foremost responsibility, rather than taking it to an advanced research level. If we can start sensitizing the stakeholders, surrounding to our university, to our state, I think that would be a great contribution. We have a lot of expectations, and I'm very happy to be a part of a webinar where Prasad Dev, who's an expert from Purdue University and the University of Texas, is with us. Sir, thank you very much for gracing the occasion, and I'm sure your guidance would help all 170 plus attendees and all those questions. I'm sure Sanskriti would be managing, because we would be getting certain questions also on a Facebook and the your live page of your institute, director of the institute, and all other members and the team of the Institute of Climate Change for supporting this event, and we look forward for many such webinars in the future. Thank you one and all, and I hope it's going to be a very, very interesting webinar for all of us. Thank you.
Thank you, sir. Thank you for your kind words, and also for your constant support and guidance which we have been receiving. In fact, this institute was instantly given support by you as well as the entire syndicate as soon as the proposal was put up. And as you mentioned, the idea is to bring everyone related to climate on this platform, not just the meteorological or the technical aspects, but also other subjects like health and hygiene, biodiversity, as well as economy, and several other subjects which are touched by climate change, because there is hardly any subject which is not touched by climate change. So thank you, sir, for joining us and for your kind words. Let's not waste time. I will like to hand over the screen to Dev Niyogi, sir. But before that, a brief introduction about him. Professor Dev Niyogi is an expert in atmospheric sciences. He did his PhD from North Carolina State University. He was a former state climatologist for Indiana. He's an editor for remote sensing, review editor for climate research, associate editor for American Meteorological Society Journal of Applied Climatology and Meteorology, editorial board member for Urban Climate. He's the immediate past chair for the AMS board on urban environment. He is the elected board member for International Association of Urban Climate, and his areas of expertise involve severe weather, urban climate, monsoon processes, and tropical cyclones, agroclimatology, and land data systems. He is a recipient of several professional awards. The list is very long, so I will not include that list over here. I will request everyone to look at his profile. And he is also having associations with some of the very premier institutes for the topic of urban climate and monsoon research groups across the globe, and also across India, which includes some of the premier institutes like IIT Roorkee and IIT Bombay. He has also been associated with Indian Institute of Sciences, Bangalore for a very, very long time, and is on the panel for Department of Science and Technology, as well as for the GYAN projects of Government of India. He has been invited for giving expert talks almost in all the IITs of India. And personally, if I would say, I have been associated with him since 2014, and right now he is also as an advisor to me on both the climate change projects which I am carrying out, which are funded by Climate Change Department, Government of Gujarat. So thank you, Professor Dev Niyogi, sir, for accepting our invitation and agreeing for this very important topic on a very important day. Over to you, sir.
Thank you, Sanskriti. Thank you, Vice Chancellor, Professor Parimal Vyas, Dr. Chudasama, Registrar, and all of the people who are here. I think Vice Chancellor Vyas laid it out very nicely by saying that we are in an era where we are starting to see many of the changes that are now being manifested itself, and we are facing newer challenges. And he raised a couple of very good points about trying to create a network and starting at a foundational level, and also looking at agriculture at some of the climate change impacts that will be starting coming up. I think I encourage the Institute and the university to continue with that, in the sense that I would share that the Department of Science and Technology has a very forward-thinking agenda that I've been extremely impressed, and they have created a network program for climate. And under that, there is one on urban climate that I've been very fortunate to be involved with. And uh, and we have Baroda on one of the activities that are going to be emerging in coming years. And we have indeed had the pleasure of having Professor Sanskriti Majumdar come and present those ideas to us. Agriculture is indeed a very important topic, but majority of people also stay in cities. And so looking at both the cities and agriculture, you start looking at the impacts of climate and the solutions that are available in a very cohesive manner. And indeed, in the context of foundational aspect, this is where I'll be going with my talk today. Um, I will start off from something very foundational, and I hope I've been looking at some of the questions that have come up. I do understand there will be people who will be going from an extremely basic level to some who have been experts in this field. But by nature of what this talk is on the World Environment Day, I would request that those of you who can't find this in a more technical or technologically intense way, please do have uh, a, a means to, please do have a basis to have it via email or some other ways. I want to say that today is the World Environment Day, and you can send me an email on any of those things that you would wish to follow up following this particular talk. But I want to share, first of all, that today being the World Environment Day, just for some of you who may not be aware, what is the history of that? It started off in 1972. On 5th June, there was this so-called Stockholm Conference on environment. And this Stockholm Conference was looking at how do we start looking at this human environment. And it was on this particular day, June 5th, that this conference looked at this issue holistically. And on 5th June 1974, the first theme of only one Earth, which we now understand into this context of, we are managing global resources, has emerged. And so on 5th June, we start looking at the World Environment Day to highlight the importance associated with the environmental issues. This year's theme is time for nature, biodiversity. And last year, in fact, it was air pollution. So perhaps next year it will be public health and so forth because of what we are doing through COVID. Speaking of COVID, I wish all of you are safe, you and your near ones are safe. And indeed, in fact, if you start looking at how this COVID-like situations have emerged, it is essentially an urban problem to begin with. That's where we had higher density of people staying together. So everything we talk about in the context of urban processes are not just restricted to climate, but when we do things which are good for the climate, we are doing things which are good for the environment. And also perhaps we have to find creative ways how to do this for the economy. Here's just one of the logo talking about the celebration of biodiversity and the time for nature, that we are all looking at an integrated spheres of building bridges, interactions, and so forth. It's indeed a time to rethink what we do, a resilient future that we are looking for, and clearly a need for a generation of resiliency. And that's going to be one of the themes I'll keep talking about. I also want to highlight that embedded into this whole thinking is this notion of the idea of what we've been talking about: reduce, reuse, and recycle. But there's a growing focus that we should also be doing refurbishing. We should be repairing, regeneration, and so forth, the whole the concept of circular economy. So if some of you are looking into this topic, and I'm trying to look into the future, there are two things I would like you to be more familiar with. One is the so-called Sustainability Development Goals 2030, SDG 2030. For especially for students, this is something you should start becoming more familiar. And the second one is this concept of circular economy, that how do you integrate climate solutions, environmental solutions, and economy all put together such that the solutions that we are developing are not just helping environment or not just helping economy, and they're interlinked with each other. So that would be the challenge that I think the coming decade we will have, as well as the opportunity of what we will be wanting to do. I want to thank the Institute of Climate Change Research at Maharaja Sayajirao University, Baroda. You already heard about the objectives and mission. It's a official institute of climate change research right in your neighborhood there in Gujarat. It is in fact the first institute to do climate change research, and I'm very pleased to be associated and working with this. I thank the organizers, particularly Dr. Sanskriti Majumdar, for hosting this and for all the support we have received from the Dr. Chudasama and Vice Chancellor Vyas, who have, of course, graced this discussion to begin with. I also want to acknowledge these people in the background who are making this possible, particularly Chirai Pandit, Akash Patel, Neerav Agarwal, Madhav, and Meet the Way, and Achal. All of you, thank you for doing this, and they will be the ones who will be helping with the questions and any follow-up that we'll be doing as we go. You can see on the screen some of the objectives associated with this institute, and I would request you that if there are some things that you're interested to follow up with Dr. Sanskriti Majumdar, you'll find in her and her colleagues a very strong group that is interested in trying to do something good and helpful for the community, and I've certainly helped that. One of the research that this particular institute has been doing has been looking at how the temperatures have changed in a city like Baroda, for instance. And here you can see there are 4 graphs that you should see between the winter month, summer month, monsoon, and the post-monsoon period. And they start from, say, about 1969 until 2017. And as you can see, no matter what season you're taking, there is a definitive trend, meaning that the range of the maximum and minimum temperature is decreasing. What that means is that our nighttime temperatures particularly are coming higher and higher, and so the range over which the temperatures are changing is decreasing, and we are getting warmer on an average. This is a definitive signature that you're starting to see in places like Baroda and other cities, and as to how our nights are starting to get warmer. It's not just with the temperature. In fact, if you look at the other finding that their research has done at the Institute, they have found that the extreme rain events in these cities and places around Baroda have started to increase. And in particular, earlier you could have, say, about a quarter of your annual rainfall coming from extreme rains. Now it is almost a third of your rains are coming because of extreme rain events. In fact, you can see the total very heavy rainfall. What used to be about 11 events are almost now 30 plus events that are around 30 events that are taking place in this particular decade, and this number is only growing. That means when it is raining, and it is raining way more heavily than it used to before, and so you have an increasing temperature and you have increasing rains that are actually seen in your neighborhood. Another study that I really liked is if you looked at how a city like Baroda has changed, you can clearly notice that there is a dramatic growth in the urban land cover, the built up area. And you can see that by the red mark that is seen for, say, the region in 1980s, then say in 2000, 2011, and more recent years. The city has essentially expanded and become twice of what it used to be. So now you have increasing temperatures, you have increasing rains in a more intense way, And a city which is packing itself with more infrastructure, becoming bigger, is becoming more vibrant, and having all these instances of which has to cope up with the changes that is taking place in terms of its setup. Interestingly, what is happening with places like Vadodara is not unique. It is a feature that we are seeing indeed all across globe, and more so in India. In India, this is a study and a map one of my good friend and colleague Chandra Kishtawal, right from the Space Application Center in Ahmedabad, he created. Um, it shows that essentially, if you look at these lights, night lights, these are cities, and you can find how you have these pockets of very intense growths of cities that are going across India. And the kind of growth that you have seen in Vadodara is not unique, as I mentioned. Each of these cities is in fact expanding and experiencing somewhat similar problems associated with increasing temperature and increasing extremes in the rainfall. And so that's something we should be thinking about. Now, when you look at it in the context of the monsoon rainfall, this is indeed something that has been going on in the last decades, that your low rainfall values are decreasing, the number of events where you have relatively less rains are decreasing, and your extreme rain events are starting to rise. And so this feature is pretty much well known regarding the monsoon rains as a signature associated with climate change. What is very interesting, though, that when you look at which of these extreme rain events are occurring in the Indian monsoon region, majority of these events are occurring in and around urban area. So it is not a countrywide feature, but mostly where you have cities, you have increase in the extreme rains. Now it just so happens that we have cities in so many places across the country, and that is the reason we start seeing the signature across the domain in terms of the average associated with it. So one could almost say that the increase in the extreme rains in India are intimately linked with the urbanization that is going on in the Indian context. So whether it's India or other parts of the globe, one thing we are clearly seeing is that climate is changing, extremes are rising, and more cities and economies are becoming vulnerable than ever, whether you're talking about cities like Atlanta or what we saw in, say, the flooding that took place in Chennai and other cities that are around the country. Uh, you have the same story. You have cities which are becoming bigger. You have cities which are getting more rains, and you have an environment and a cluster which is becoming more vulnerable to extremes such as flooding and extreme heat that occurs. So that brings us that the need for trying to develop a climate resilient city framework that would be very relevant to how we are going to look ahead. So again, as I mentioned, by nature of this talk on the Environment Day and knowing the broad range of this audience here, I'll be mostly talking about it in somewhat um, introductory sense. But if there are questions or specific issues that come up, I understand there's a question and answer session, and certainly we can do it over email or a follow-up conversations with some of you who are highly specialized in this topic. So let's just look at this. What is this climate resilient cities? So let's first start with climate. In the context of climate, it is important to understand that we experience weather. It is the things that are happening now at this instance. Climate is something that is happening over a long period of time. And it is something that has been going for many decades. It is something that has been having a pattern that is seen over a long period of time. And what is that long period? Is roughly around 30 years or so, which, that's typically taken by the community as a period required for developing climatological changes. So examples of that could be with the things that I've seen, for instance, in the manner in which the snow cover has changed, the manner in which the CO2 levels have changed over the years. In fact, for those of you who are in climate, you might recognize the curve on the right is the famous Keeling curve, which shows the changes in the CO2 level and has become one of the iconic signatures of climate change across the community, in the manner in which CO2 levels have increased what was around 315 parts per million to almost about 400 parts per million now over a period of time. And that has been one of the drivers associated with the uh, economic, in terms of the climatic changes going through. The other thing that comes up in the literature, and I just wanted to highlight, is the difference between climate change and climate variability. Much of what you see in terms of the context of these long-term changes are climate change features. But you might have also heard of things like El Nino, La Nina. Uh, some of you might have heard about Indian Ocean dipoles and some other features. Those are more short-term, multi-year variations that take place, and they affect our climate indeed. And so those are climate variability signatures that we talk about. So whether that the way we experience is a combination of your daily weather, it is a variability that is associated, and a long-term change all put together, and you're going to experience what happens with regards to your setup. So if you look at it in the context of the global warming, because you are looking at every observation averaged it over the globe, it is not like one value that has been measured, it is multiple values averaged. We have seen a change in temperature roughly around by a degree or so, and is expected to continue to rise. But cities in particular are going to have a different threat. So that is climate. Now let's look what is resilient. In the context of resiliency, you should be aware of four things. First is exposure. You need to understand when you're trying to look at trying to make a system resilient, that what is it that you're trying to make the city resilient against. You want to make it resilient. If you are living in an earthquake zone, you're concerned about making it resilient to earthquake hazards. In the context of normal terrains, which are outside the context of earthquake. And if you're along the coast, you might be concerned about its sea level impact and storm surge aspect, as places like Mumbai have this issue. If you're somewhat inland and you're not affected by these two hazards, then you would be looking mostly at threats associated with, say, the heat stress or flooding that we are starting to see. So that could be the exposure. The second thing you want to identify is what is the sensitivity. Now, when you look at when you have a heat event or a particular flood event, which part of the city or where do you have impacts that are disproportionately higher than in other places? So you might find regions which might say slum housing or places where you have lack of trees. Those could be the places where you can have maybe more flooding, more heat stress that is occurring. And so that is obvious, but there could be some other non-obvious sensitivities that people might have or economies might have within that setup that you should need to start identify. The third is, given the exposure, given the sensitivity, the combination of those two, you can start identifying what is the impact associated with it. So if you have an event which could be, say, 1 inch of rain or a 1 degree heat wave, what could be the impact on the sector, on people, and so forth. So that's the impact assessment that needs to be done. And once we understand the exposure, sensitivity, and impact, or the vulnerability, we then start developing an adaptive capacity, meaning that when you have an impact, how can you create a community that is able to withstand that shock? It could be that you had um, a flood event, and within a couple of days you're back and running as if nothing happened. Or there could be some communities which could almost feel like they have lost 5 years in terms of progress. So there are several resiliency toolkits that are available, one of which I can suggest is the US Climate Resiliency Toolkit that is available through the US Environmental Protection Agency. And they also identify several steps that have been set up for developing this kind of work, where you explore hazard, identify vulnerability and risk, investigate options that may be available to address this kind of vulnerability. Then you prioritize working with the community. Which of these vulnerabilities do you want to target first? And then you take action to reduce this vulnerability and improve resiliency associated with the system. So in the context of resiliency, it would be that you have a functional capacity that you were performing, and then you had a shock because of a hazard, and then your functional capacity reduces. And then how do you come back? What measures are required to become back to normal or even better? that becomes the context of developing resiliency. So for instance, after COVID, we had a shock in terms of economy. How are we going to come back to normalcy? That is going to show the economic resiliency of the regions and so forth. Lastly, take me to the context of cities. And as you look at cities, we know cities are extremely important drivers of economy, culture, creativity, branding. I mean, when you think of a um, city like New York, perhaps some image comes to your mind. When you think of Paris, some other image comes to your mind. When you think of uh, places that you have visited, every city has a certain branding and image that comes in, but they're also very important regions of economy. For every rupee that is invested in the city, the returns are roughly to the tune of 10 to 15 rupees coming out of it. So there is a very high return of exchange that comes in. But what is important about cities and why we study cities is that if you look at it in the context of the globe, temperatures are expected to increase by 1 degree, 2 degree, depending on what models you look at. But if you look at a city right now, and if you saw the example of Baroda, for instance, in the last 20 years, just because of the growth in the city and the activity, we are starting to see how cities can start becoming warmer. And we start getting an example and understanding as to how we can look at what can potentially go wrong so that we can study and come up with solutions that are applicable not just for the city, but for the entire community and the globe beyond that. I mean, we have seen problems associated with urban sprawl, for instance. We have seen problems associated with pollution and congestion, with traffic. We have seen air pollution, studies that are going on, the issues that are going in. We have seen impacts associated with weather and flooding. So all of these features that we are expecting to see in a warmer world, we are already experiencing them in cities now. So when we start developing an understanding of these problems and the solutions that can be tested here, we have a template for taking the solutions to a much broader community beyond the realms of the city that is going. So I spoke about city. So what is a city? So let's think about it for a moment, because when you are thinking about a city, perhaps this is what comes to your mind: a setup of structures, buildings, a lot of infrastructure that might be looking as a city. So that might believe as to be the first footprint. But if you look at it in the context of transportation and mobility as to what could be the impact of a city, you can see several people don't just stay in the city, but they stay around it. So you have this mobility and traffic and sprawl that is around the city. So then your definition of a city starts becoming much bigger in terms of the context and the exposure and the impact it is going to have. In fact, if you start looking at it in the context of what might be seen with regards to a environmental feature, cities are where we have majority of emissions taking place. And then you can see that the impact associated with the city is going to be much, much larger than what happens over just the footprint associated with that city. So even if I showed you that a city like Baroda has grown from 80 square kilometer to 170 square kilometer, you can be assured that the impact of that particular city is not restricted along its boundary, but is much wider in its scale and impacting an environment which is much wider beyond the boundaries of that particular city. So whatever definition you apply for looking at a city, beyond the clusters and beyond the influence of environment of humans, we can start thinking that cities have a much bigger, wider, pervasive, and significant impact onto the environment around us. So how does this environment that is now expanding and affecting a region around it actually affect weather and climate? So if you look at it in the context of the most basic things, we have this feature associated with the setup of changes associated with the heat island. So cities are much warmer than the surrounding area. So you can see this particular zone of where you have more concrete seen in the top image with the white looking satellite imagery. You have the green trees and the white parts are the urban areas. And below that is a equivalent temperature map. You can see that the urban areas are much warmer than the surrounding rural areas, and we call that as a heat island. This we know. You can see that even in places everywhere with satellite data or surface data, that cities are much warmer than the surrounding area that come in. But cities not just affect the region in terms of the temperature, but when you have a change in the temperature because of the heating that takes place in the building material, the roads, and the infrastructure, it also starts changing the manner in which you're going to have heating, and the winds start coming in. The warmer the temperature, lower the pressure. So surrounding higher pressure area, winds start coming in. And when you have this, what we call convergence, you're going to have a potential for convection or cloud formation in and around the cities. And that's one of the reasons why we start seeing rains that are associated with the heating and the pollution and the moisture that comes from the city, adding to the background and creating an even more vigorous environment around it. So you can look at it in this particular cartoon where you can see the city starting to warm up. You have this moisture coming in, winds coming in, creating the clouds, and downwind of the city, you start seeing more of this rains going through. So now think back about that extreme rainfall events that I was talking about, and how the cities add a extra punch in creating those rains even more intense, even more stronger than they used to be. And in fact, for some of you who are interested in this topic, there has been a large comprehensive review we did, and you can see how rains in and around cities are changing in a meta-analysis perspective that's going on. So given this context that cities are changing the climate, how do we design cities to become resilient? That is a question I will quickly try to look into if we have time. Uh, the goal here is that we want to make technology effective to be designed in the manner in which cities can be put together. Let me highlight again that vulnerability is risk times exposure. If your risk cannot be changed because you can't stop a thunderstorm coming your way, you can't stop a cyclone coming your way, you can't stop a heat wave coming your way. But what you can change is the exposure. And how do you change that exposure is by designing or developing tools that are available for the community. And this is where we start looking at technology as one of the means of doing this. So first thing we do is trying to really understand how do you come up with a detailed understanding of our cities. If you look at it in the context of our larger globe, we are essentially looking at the globe in a very coarse perspective. And then as you go finer and finer and finer and finer, you start seeing that we are able to understand, view, and represent better details. Now, it might be intuitive that why don't we just simply go for higher resolution studies? The problem is computational cost, that you can't simulate and study such processes at a very large scale with the computational power that we have and the speed at which we want to make decisions. And so we always compromise. The second is also our understanding of the science, that how do we represent these processes. So it's a very interesting, important topic about what is the optimal resolution to be used that is computationally and decisionally wise. But when you start going with models, weather forecast models, climate models that go from higher and higher and higher resolution in terms of representing the processes, we are indeed able to represent some of the urban features right, and that can be provided as an input to the policymakers, to decision makers. Now that is at one level. But when you look at it in the context of a global context, because you're not just trying to do it for one corner of the city, you're trying to do it for the whole city, not just one city, but many cities in the vicinity, then you have to look for satellite products to look at it in a global context. So you can look at many data sets that are available openly to the community, start putting this data together, and try creating some rules to start mapping the city and framework. In fact, there's one such things we have been doing, which is called the World Urban Data Analysis and Portal Tool, or WOODAPT, and we have developed maps of all the cities in India, major cities in India, Baroda included, and we have these maps available as to what is a high resolution setup associated with the city. This one is for Bangalore, for instance. And you can start using such information for creating a resiliency analysis going ahead. That is at a large scale. But when you're trying to do it in a more context scale, we don't often have data. So how do we then do this in that particular scenario. Now, here's another example of how technology is being used. And this technology is what we have been doing with video games. So in a video game, you can actually start looking at a terrain. You can create your own graphics about where the roads might be, what kind of blocks and parcels could be there, and you can create your own buildings going ahead. So in that context, you have a setup where you can create a sketch where you create the data set. You can say, okay, here's my city, here's some of the work, here's some of the terrain that we have. A river might be going, and we have a city which is growing. First, it was small, then it has become bigger. The buildings were smaller or taller, and we can use that information in our models in trying to develop how we want to set up. You can then we can also try looking at it in the context of how these particular cities are affecting the weather by providing this information into your weather modeling framework going ahead. So the idea I'm trying to present here is that you don't necessarily always need to have really high resolution detailed satellite data. You can create your data set with available tools and even some of the technology that is there in setting up with the kind of solutions that you're trying to look here in the context of developing city and city maps and how you want to use it. In fact, we are now developing this technology using satellite data sets, looking at some of this video gaming and computer graphics, and creating artificial cities that are available for creating these tools that can be used towards developing cities. Now, here's on the left, you'll see the Google Earth imagery of Chicago on the right. And on the left, you will see the imagery we created using computer graphics. And you can see there's a pretty high degree of match. Here's the city of New Orleans. You can see the details that are pretty well captured. In fact, from this, what we call the graphically generated city, if you look at it, now what is the advantage here is that you can start looking at that city as if you are flying over it. You can get all the details you want. You can see how the buildings are. You can see the kind of details you have with regards to the width of the building, the height of the building. This is for the city of Toulouse in France. This is for San Francisco. So idea here is that you don't necessarily need high resolution, expensive LiDAR mapping or studies associated with satellite. You can use available technology and create good enough data set that can be already digitally interfaced with the models in terms of creating the setup. Now, here's another example about how we are creating an image where you can look at translating this particular imagery into a model where you take a picture, draw it, then that picture, you just by click of a button, it is converted into a different kind of a contour that is taken into the city. And you can start creating clusters of this data set into the setup. And given this, you provide this information to the models for what could be the height of the building, the width of the buildings, and all that features that are required. Why is this important in the context of what I'm talking? This provides us with the tools to realistically simulate the situations where people can then start visualizing what happens if I make my buildings bigger? What happens if I make my areas which are greener? What happens if I start changing the green cover? What happens if I start making my roofs white? What is the impact of technology in trying to make this impact onto the environment? Will it be making warmer? Will it be making cooler? How do I change the city in the context of some of the region that I'm associated with? Where do I put solutions? Like if I want to create a green patch, where do I put it? Do I put it in the middle of the city, away from the city? Where will I have the best impact coming out of it in the context of what the city does? What can I do for designing a traffic in the city? All of this that you're seeing is computer generated here. About the cars and the flow and what it can be done in terms of simulating into a completely cohesive living urban environment that you can model using computers now. This has an impact that you can actually start looking at what could be the impact on air pollution, the flow, the time it takes from going from one place to another, and you can come up with solutions that are available. So this feature about understanding urban climate We have a really opportunity here, a real opportunity here to create technology, our understanding, and coming up with solutions in developing rules, in developing solutions. Here's an example about how can you make cities more flood proof, and you can come up with solutions about putting up, say, sponge like lawns, or you can come up with changing the building heights, and you can sort of like come up with solutions as to where you can have higher risk of flood, lesser risk of flood, and so forth. I want to highlight by saying towards the end that we now have a grand challenge, that we want to make cities resilient. We have an understanding how to make this resilient. We have people willing to try and do something. Now it is up to us as technologists, as academics, to try and present the best solutions that people can visualize and understand and evaluate. And doing so, we can come up with solutions that everyone can have an insight into, that what are we trying to do here and how can we save. Now, this is a place where we can have all different groups with extremely different background, whether it is in infrastructure, whether it is in policy, whether it is in computing, whether it is in environment, all coming together as the city does in trying to come up with solutions where we can have this kind of solution-based laboratory that can go through. I will end up right there and say that I would be more than happy to follow up via questions, either here or via email. I apologize that I went over for a few more minutes than I should have, but I really hope that we can have this dialogue to continue. So the take-home message that I will have for you is, look into the context of circular economy, look into the context of sustainability development goals, look into the context of artificial intelligence, machine learning, some of the satellite data sets and rules that are starting to form. It is a completely new area. You can start thinking of however you want to apply it for a problem. And you will find that you can insert interfaces to develop these models that can go into weather and climate or hydrological scenarios. And you don't have to look at the problem of climate and climate change into this old framework where everything is happening globally and you're looking for this data from some large computing system and start doing your role analysis. You can start creating your own data set to study the problem, study the solutions, and then come up with analysis. Whatever you are impressed by in your mind that this is the solution I can offer, test it out. You have the means available to do it. And I hope on this World Environment Day, it is that positive message of hope that I can pass on to you, that climate is not just something that is happening to you. You can do something to have a climate you wish to want. So I'll stop there and thank you very much.
Thank you, sir. You have been very, very smooth, and your language is always so simple for anyone who is even a layman in the person of in the subject of climate change to understand. And as you can see that the audience actually includes many people who are not uh, directly involved into the research, but I'm sure that your talk has ignited minds. So there are some questions, and I will pose those questions to you one by one. Maybe you would like to address those questions.
Sure.
Uh, there is one question from Dr. Rupali Goyal, and she says that, sir, can you give an example of existing fully developed city in which climate resilient cities have been created using technological applications?
Yeah. So let me repeat the question. Are there examples of a city where we have climate resiliency solutions being done? Now let's think about this way. You don't need to change the whole city to come up with climate resiliency solutions. As I mentioned, you need to identify parts in the city where you have high degree of vulnerability. And when you make a change in that particular part of the city, you have an impact that is being done there. So there are several examples that are out there. Um, uh, if you look at that US climate resiliency toolkit, you will see several case studies that have been documented. It is publicly available. The second one, I would say, within the context of India, there is the Department of Science and Technology Urban Climate Network. And that network program is indeed looking into identifying such solutions and cases that have been done. So the cities that have been identified are, say, for Hyderabad or Pune or Bhubaneswar or Haridwar, Bangalore, and indeed we are working with Vadodara and Nagpur and few other places to go with that. But even from the context of, I mentioned Bangalore, they have been having a project where you are looking at flooding and how the Karnataka State Natural Disaster Mitigation Center and Indian Institute of Sciences and all their cohorts and partners are working in creating solutions for a specific problem associated with urban flooding. There have been cases where people have been solving in parts of reducing the air pollution loads and so forth. So again, when you are trying to see examples, don't think of the whole city, see what solution and what part of the vulnerability a particular technology has addressed. And again, the US Resiliency Climate Toolkit will be a good example. You can also look at places like Netherlands and Rotterdam, how they have created pathways for flooding versus bikeways, and solutions that have been created for malls, which have these fountains, which can also have um, barriers for water coming in and so forth. So I'll be happy to share more with that. Please send me an email.
Right. Thank you for addressing that question, sir. There is another question, that why is extreme rainfall more likely in cities? Is it because we pollute and waste more water in cities? Sir, actually, I would suggest that you give a little more explanation about the urban heat island effect, because probably not everyone would be aware of that.
Sure. So let's understand this. Cities, as you know, that have lots of buildings, roads, cars, all the activity that is going in. Each of this activity, when you have radiation coming in, absorbs heat. If you're outside the city, you can often find it is much colder than going into the city. And this is because the cities have this heat that is absorbed by multiple parts of the city. Roads become warmer and so forth. So when you have the heating, you have more moisture in the more temperature in the city. That is obvious. The second thing, which we don't often see, is that with increasing temperature, the air in the environment in that city has higher humidity. There is in fact, a very, for those of you who know thermodynamics, there is a thing called Clapeyron equation, that as your temperature goes on, the ability of that air to hold moisture also increases. So when you have increasing temperature and increasing moisture, you have this capacity to increase the energy of the environment. We call it the convectively available potential energy, or CAPE. When you have this higher potential energy in the environment, and if you then start getting triggers like pollutants, as you mentioned, clouds that are being formed, and these polluted particles can get into the clouds, or when you have winds that are coming in, then you have this potential energy adding to the kinetic energy of that wind, and together they become an explosive storm. And then you can start having locations where the rain can start falling. So think about it like a bag full of water that is over a city, and it could have passed away. But now that you are putting more water in it, it starts bursting because it doesn't have the capacity. And then you have more rain occurring downwind of the city, or getting just impacted in terms of the whole feedback. So the mechanism is indeed a pathway about all the processes, but it boils down to more energy and a trigger for that particular cloud convection system to burst out in and around the city.
Yeah, thank you, sir. Dr. Shagufa Kapadia has a question. She says that, can you pinpoint 3 aspects that we as individuals may look into facilities for resilience to climate change?
Um, to facilitate resiliency to climate change, I would say that it really depends on, at an institutional level, you can start looking at it in the context of, as I mentioned, the steps that I've done. Where are you looking for resiliency? Identifying that first. Second, what do you want the resiliency for? Is it heat? Is it for water? And the third one would be what could be the adaptive actions that you would want to take, whether it is things like growing trees, or whether it is a matter of coming up with a policy thing, or whether it is coming up with rules associated with things that are um, relevant for the policymakers like city planners, or whether it is engineering solutions. As I mentioned, uh, instead of just having parking lots could also have places where there could be uh, water storage in case of a flood, such that the water comes in there and then it can be passed on and so forth. So there could be several engineering solutions, policy solutions, or more academic assessments that could be done when you're trying to come up with resiliency.
Right, sir. There is one more question from Lalit Kumar Gehlot. He says that he would like to know what are the likely chances that a large-scale atmospheric circulation would affect the basin, which is on a smaller scale or for a small-scale climatology.
Oh, none of the weather or none of the climate is restricted to a particular boundary. As I mentioned, for Baroda, for instance, just because Baroda is 170 kilometer doesn't mean that the weather is restricted there. It is affected by the large scale systems that are coming in. Um, but when you're looking at a particular location, we need to be aware, exactly as the question poses, that there is a large scale influence and then there is a local scale influence. And adding this together, you're going to get a sense of the real understanding. Very often, people perhaps might forget when they're analyzing a particular location that they might only look at the large scale features and forget the local scale analysis. And then you might have uncertainty, or you may not be explain everything. In other instances, you might be always looking at only small scale changes and forgetting these large scale influences. So combining it together, you will have a much more comprehensive picture about what is causing the change and what solutions might actually be effective.
There is one more question which is more related to the cyclone Nisarg. It is that what can be the possible reasons for temperate cyclone Nisarg? It just broke all the trends. All cyclones shift northwest towards Oman, but this just went in the opposite direction. How can we prepare our cities to become resilient for such calamities?
Yeah. First of all, I'm really glad that it went away from big cities. And at one point, it was pointing to go towards Mumbai. And we all know that Mumbai, if it had occurred with high tide, there could have been another instance of a flooding, and it could have been a even more economic and health and human shock to a city that is very close to me. I'm from Mumbai, but also for the community and impact that you have around there. Um, Now, with regards to the question that it has broken records, I think it is not unusual to have cyclones. Uh, yes, we have cyclones more often in the Bay of Bengal, but we also have Arabian Sea cyclones coming in. And it is not always that they go towards Oman. We have had cyclones which have gone to Gujarat. There are cyclones which have gone to Maharashtra and other places. And so it is in the context of how the system works. Each cyclone, each weather event deserves respect to be studied uniquely. We can get general characteristics by looking at range of climatology, but each event is going to be unique and it is going to have unique features going in. Now, why this particular went south and so forth, that is a matter of study that will go on, whether it was associated with the large scale wind patterns, whether there was an effect of anything to do with the lack of pollution, because it'll be interesting for you to know that the atmospheric pollution, the dust in the atmosphere, has an influence on cyclones. And so when we are into this particular environment where there is less dust, is that contributing to cyclones? We don't know. And that's one of the things we'll be trying to study.
So people would like to know more about what is carbon footprint, because we have people from all backgrounds.
Yeah. So a carbon footprint is in the context of changing climate, one of the biggest ways that we have been looking at the changes in climate. If you recall, I showed you that one particular slide related to the changes in the CO2 levels, the so-called Keeling curve, as to how carbon dioxide levels have been moving from, say, 350 parts per million to about 400 parts per million in the last 5 decades or so. Now, obviously, this carbon change is not happening in isolation. It is a contribution of individuals, of activities and industries and processes all added together. And part of that, which cannot be used as a sink, meaning like into the ocean or by photosynthesis, is released into the atmosphere. And that starts becoming available as free carbon that changes the environment. This goes down to the context of the greenhouse gases like carbon dioxide, methane, water vapor, and so forth. And they have the ability to change the radiation and change the climate. So what is a carbon footprint? It essentially is that if you're looking at any activity, how much carbon is emitted by that activity. It could be that you look at it in the context of your own thing. If you are drinking coffee, you had water that came in, but you made coffee by heating something. So how do you see that how much coal might have been used? So there is something known as a life cycle analysis. You can do this life cycle analysis of any event in a very narrow way by just saying, okay, how much electricity I'm using, how much water I'm using, and what might be the rules that I can use for converting it. Or you can do it in a very detailed way, that if I'm going to go to a particular coffee shop, like a barista or whatever, and I'm going to get a cup of coffee, how much carbon did I consume driving to that store? How much carbon did it consume for that cup of coffee to be created? What does it mean in terms of me just drinking that coffee? How much carbon got consumed? Everything we are using in and around us consumed some carbon. And it really depends on how do we analyze it, and that's your carbon footprint. So you can reduce it by the context of being judicious. First of all, the first step towards change is recognition of what it is that you want to change. Once you understand that, then the second step would be how do you change it? And those could be the steps that you can start looking into. Your reduction in the points I mentioned about reduce, reuse, recycle, refurbish, repair, and then re-energize and regenerate. Those could be some of the ways that you can start looking into this whole circular economy, reduced carbon footprint framework.
Sir, Parul Sharma says that you have been talking about urban areas, but what should be our strategy for rural areas, which are also vulnerable in many ways, including the socio-economic aspects?
Absolutely. None of these things, whether it is urban or rural or agriculture or water, you can look at it as a silo. Everything is connected. In fact, if you look back to the first premise of the World Environment Day, 5th June 1974, it is the one world. So in the same context, whatever we are trying to understand, whether it is for city, the tools, the technology, the message is similar. Look at vulnerability, look at the way to analyze that vulnerability, identify solutions that you can solve towards it and do it. Now, in the rural context, some of the problems would be different. It would be things like, how do we come up with tools associated with planting? Or how do you come up with tools of access to water? It could be issues like, how do you come up with the balance between energy and water use? There is a whole different set of tools that are available. And in fact, Parul, if you are interested in this, send me an email. There's a whole different set of literature that I may be able to share with you, and even some websites associated with that.
Right, sir. Sanket Shah would like to know that how do you see India preparing with respect to government policies, smart cities, river linking projects, Ganga River Clean Mission, etc., against climate change emergencies?
No, I've been exceptionally proud and pleased the manner in which India has been leading in on this particular topic. As I mentioned, for instance, the Department of Science and Technology has a climate change program and dynamic leadership there, and the whole series of thinking there about creating networks and centers and paradigms of studying this together. I think I'm very pleased in manner in which this is going. So in the context of individual aspects, yes, there are numerous groups, numerous studies, numerous projects. They're not just doing this academically, but they're actually having an impact in terms of what's happening on ground, in terms of policies and so forth. You may or may not often read about them because different groups have different way of advertising the work that has been done. But I would say if this is a topic you're interested, uh, uh, I highly encourage you to go deeply and in fact follow up with me if you wish to, and I can connect with you on that part. But I would recommend, for instance, looking at the Department of Science or Technology, the Ministry of Earth Sciences. There is also the Indian Institute of Tropical Meteorology. There is a Climate Change Center, Research Center, ICCR, and so forth. They have been doing some dramatically beautiful assessments on all these topics. And I encourage you to get in touch with them to try and see. And of course, the Ministry of Environmental and Forestry and so forth. Point being, this question, very important, lots of things going on. Sky's the limit to get information.
Right. In fact, climate change itself is a very, very wide subject. And there are so many aspects for which everyone is still a learner uh, for all of us. But sir, there are questions coming, as you can see in the question and answer section over here, as well as on the Facebook. We will continue only if it permits, time permits for you. Maybe
Sure,
I'll take up one last question and then let you decide whether you want to take up more questions. The question is that why is it that deserts and semi-deserts are now receiving torrential rain, which was not there previously?
Whenever such a question comes, not just for this particular thing, I think it is very important to understand the time period you're considering when you say previously, whether it has never occurred and so forth. But I think I'll just go into the generic aspect that why are some areas where we did not have rain before getting more rain, and why are some areas where we expected rain are decreasing? The reality is that it's not just the amount of rain and temperature that is changing, it is also the manner and where it is raining is changing. In fact, we had a study we just did for a city of Hyderabad, where you are shown that the timing of the rain is changing. It used to rain more in the afternoon, it is now raining more in the evening. So it is a space and time changes in the rainfall that is going on. And again, this is a combination of what we are seeing with some of the local changes and large scale changes. Remember that there are large global changes that are going on. The manner in which the Arabian Sea is warming, manner in which the Indian Ocean has been changing. So the manner in which some of these cloud systems that bring rain coming in are also slightly changing their orientation. So all of that features, when you look at it together, you can start seeing a new sort of era emerging in terms of, that's what we call climate change. So one of the important thing, especially from the context of infrastructure design, or when you're trying to do projects related to hydrology or projects related to agriculture, we have a challenge now. We can't rely on how things were done 20, 30 years back. We have to invent and reinvent new ways of doing things and then doing them in a more positive way. So I appreciate that you are recognizing that there's a change occurring. And I would encourage and challenge you to look for solutions to address that change.
Sir, we can go on and on and on. So what do you say?
I'll be happy to take maybe for 5 more minutes, if it's okay, then because I have unfortunately another meeting.
I do understand, yeah.
Yeah.
Maybe there's one important
but let
question.
me say that I'm sorry, Sanskriti, that I really appreciate the enthusiasm and the creativity and the depth of these questions that is emerging from all of you. And I apologize if I am cutting anyone short or not addressing the question correctly. But if there is something that you have not been able to address here, please do send me an email, and I'll be genuinely interested in providing any feedback I can and helping in any ways I can. And those of you who have interacted with me before know that I'm not just using this as empty words. I absolutely look forward to interacting with all of you. And any question you might have, I'll be more than happy to provide some feedback. So please go ahead. I can take maybe for 5 more minutes.
Okay. There is one question from Soumita. She asked that is there any urban flood repository where we can have the global and national data?
Yes. So there are a couple of places where you can look for this flood repository and so forth. There is in fact one study that is being done at University of Maryland, where they are looking in terms of a global flood maps and data sets. They are even in fact using some of the large data from satellite data sets and developed a system to try and do that. That would be your first starting point. Second is your UN Spider. You probably are aware of it, SPIDER. There is a UN database that has been created for such kind of hazard maps. The third would be I believe there was a review that was developed a few years back, but again, send me an email and I can pass you more details about it. But one of the questions that are now coming up, you're probably, by your question, it occurs to me you're from a technical background. So you're probably aware of something called as a SMAP satellite, the soil moisture active passive sensors SMAP data set. As one of the follow-up to SMAP, there is questions coming up, can we come up with an inundation product for satellites? And under that inundation product development, there is this question about urban flood versus non-urban flood being mapped from satellite and that data becoming available. You may want to look into that as well.
Okay. I think, sir, we can respond to the rest of the questions on email, because
Okay.
I wouldn't like to keep you engaged over here. I understand that we have disturbed you at an odd time.
Oh, no, it's
a
fine.
working day. But I'm also glad to share, sir, that we have over 2,000 viewers on our Facebook page right now, who have heard you. And I'm sure that you have ignited many minds over here, because not all were people who are actively into research of climate change, but the whole idea of this webinar, as well as the Institute of Climate Change Research, is to bring everyone on a common platform and just ignite minds, so that people start not just getting aware of what is happening around us, but also get into active research related to that. So I will, on behalf of Institute of Climate Change Research, as well as the Maharaja Sayajirao University of Baroda, I would like to thank you from the bottom of my heart for accepting our invitation and addressing such an important subject over here on this day. Actually, whenever I have met you, I have learned so many new things from you, and I'm sure that that has been a similar case with all the viewers over here. Climate change, and especially the topic, the way you covered, is a very, very difficult topic, and research in that area is not that easy, but you have always been so smooth, and the language which you use is so simple and lucid that anyone would get attracted to get involved into this subject. So I really appreciate your way of explaining this very difficult topic so simply to all our viewers who are over here. I would personally actually thank you for highlighting the small component of research which we have initiated over here. That I thought it was more of an informal discussion which we were having. But then I saw that you have included the objectives of Institute of Climate Change Research into your presentation as well. And then all of us, the photographs of the entire team, as well as component of the research which we carried out for Vadodara, that also you have included. So in a way, you have spread a word of the kind of the research which we are doing over here. So that is a big thank you from the entire research team to you. Incidentally, when we are talking of climate change, Vadodara got its first rain over here. So that is one positive aspect which I will say, that a very nice day and to get a very first rain for this city. Just when we began, it started raining in almost all parts of Vadodara. So once again, I will thank you for your involvement in terms of the advisor for my projects, as well as for your involvement in all aspects with the university. But along with that, I will also thank all those who are involved in making this program a success, because teamwork is essential for any program. So first of all, I would like to sincerely extend my thanks to Professor Parimal Vyas sir, Dr. K.M. Chudasama sir, as well as the entire syndicate body of the university for taking up this proposal for initiating the Institute of Climate Change Research, which is, although in a very, very nascent stage, but we have very high ambitions, and we have set up our objectives, which we will definitely try to achieve in the days to come with their support. Thank you, sir, for all the support which you have always been extending, and also for your presence throughout the webinar and your kind words and address to the participants. I will also thank the IQAC team for helping us with this webinar, and Prinkit and Achal, as well as the communication cell of the university for the logistics support and the media management. I also take this opportunity to thank the press and media who have covered this webinar yesterday, today, and probably Professor Niyogi, you may get some calls for more interaction. So with your permission, I will pass on your contact details to them as well. But I have to thank my research team members who have been actually pushing me to get in touch with more and more eminent speakers and continue with this series of webinars, because it is not just a learning for us, it is also learning for all of those who are interested in the subject of climate change. So you have already shown the names of all the members along with the photographs: Chirayu Pandit, Neerav Agrawal, Akash Patel, Meet Dave, and Madhav, who have worked tirelessly behind the screen actually to make this happen. I would like to thank all the enthusiastic participants, especially the students who have enrolled into this webinar, because they are the people who will take the maximum benefit of such webinars. So I appreciate your active participation and look forward to it in future also. As I have shared couple of times that we are in touch with many eminent people in the field of climate change, which will be covering all the aspects, not just the meteorological aspects, but we will also try to rope in experts in the field of economics, in the field of policy formation, in the field of health and biodiversity, etc., which are also the subjects which are affected by climate change. And in the near future, we will be announcing more such webinars over here. So keep looking at the Facebook page of Institute of Climate Change Research, and we will be posting more details about the next webinars over there. I was looking at the chat box and I saw that some of the participants were mentioning about the feedback link. Yes, we will definitely share the feedback link, and we appreciate your feedback. Incidentally, we had sent certificates only to those who had sent the feedbacks. So it is important for all participants to give their feedback to us so that we also understand where we can improve on. So I request you to keep looking at the liking the page of Institute of Climate Change Research, and also spread a word about our activities as well as our webinars to all those who are interested in this subject, so that we can share more knowledge with them on this subject. So Thank you once again, Professor Niyogi sir, for joining us today. Once again, thank you, Professor Parimal Vyas sir, for being with us. Sir, would you like to say anything?
No, I think before you sign off, Professor Niyogi, we look forward to your visit to the Maharaja Sayajirao University of Baroda. I think we would be more than happy. And Sanskruti has also, in the institute, we have advisory committee, sir. I request you on my personal behalf, now because we are on an online platform. So, sir, I would like you to, guide us. He is from the Department of Civil Engineering, and we have a very vibrant faculty of technology and engineering. So I, on my personal behalf and on behalf of the institution, sir, I request you that you please provide your guidance and support to the university in such academic endeavor in near future. And thank you all the attendees who have joined in a big number and you have stayed with us. And this is just a beginning. I think it's a collective responsibility to see to it that we take care of nature. We develop self-discipline and we inculcate culture right from the childhood in our children, so that we would be able to save Mother Earth. I think this is a wonderful, event on the day of environment, which we are celebrating worldwide. And sir, we really feel touched with lucid presentation. I could see some queries we have received on how the presentation was also made. That was wonderful. And we look forward for a long-term continued association with you. Thank you very much, sir.
Thank you, Professor Vyas. Thank you, Sanskriti and everyone. Questions, Vyas, I publicly echo your comment, and I offer my complete support in whatever capacity I can in helping this initiative and the institute. And I'll be more than happy to be more actively involved and help with this initiative. Thank you, everyone. Thank you I really appreciate this a lot. Thank you. You all have a wonderful day.
Thank you, sir. Thank you. There are some questions which the participants have posed regarding the software used and the technologies. So I guess you can write an email to either Professor Niyogi or to me, and we will try to address those questions. I have not taken up those questions over here.
Okay.
Yeah. So we sign off over here. Thank you to one and all again, and keep looking at the page for more information, for more webinars. Thank you.
Thank you. Bye.
Bye-bye.